Jupiter. Giant, whirling, and fierce. A colossal ball of gas some 600 million kilometers away from Earth. It's more than twice as massive as all the other solar system planets combined. So large, you could fit over 1,300 Earths into its volume. If you look at Jupiter through a backyard telescope, you'll recognize it by the different colored bands of clouds racing around in alternate directions, which make up its distinctive atmosphere. It's a violent one too, with winds constantly blowing at hundreds of kilometers per hour and storms like the Great Red Spot that can last for centuries. So we know the planet is large, stripy, and extreme, but what is it that we still don't know about Jupiter? Well, first of all, we don't quite know how it formed and how it shaped up the formation of the solar system. We do know Jupiter probably appeared before the rest of the planets because it is mostly made of the same stuff, hydrogen and helium, as the solar nebula, the cloud of gas and dust the Sun, the planets, and ultimately us originated from. But did it form slowly, starting from blocks of ice and rock gradually clumping together that then accumulated gas from the nebula? Or did it form in a single step from a vast clump of gas and dust that rapidly grew in size? This is one of the things that NASA's mission Juno, arriving at Jupiter on 4th July 2016, will look into over the next few years. Juno is named after the Greek-Roman goddess who looked beneath the thick clouds her husband Jupiter drew around himself to hide his mischief. Juno the mission has instruments that will peer through the clouds of Jupiter the planet. We are not really expecting to find any funny business down there, but we are still curious to discover Jupiter's secrets. Some of Juno's instruments will determine what Jupiter is made of and how much water is present deep within its atmosphere. Others will measure tiny variations in the planet's gravity and magnetic field to find out if there's a solid core and what its properties are like. Scientists, including many in Europe, will then use these data to help us make sense of how Jupiter and the rest of the planets in the solar system came to be. By studying Jupiter's thick clouds, we can also learn more about the intense weather systems and the swirling bands in the planet's atmosphere. Why do Jupiter's storms last for so long? Are the colored bands and strong winds connected to gas motions in the planet's interior? And how does Jupiter's vast magnetic field, 1,000 times stronger than Earth's, affect its atmosphere and generate the intense aurora that we see? While Juno will tell us a lot we don't yet know about Jupiter, it won't look into one of the planet's most striking features, its moons. We found a whopping 67 of them so far, more than in any other planet in the solar system. With a pair of binoculars, you can easily spot the four most massive ones, the Galilean moons. Finding out more about them is a job for the Jupiter Icy Moon Explorer, JUICE, a European Space Agency mission planned for launch in 2022. JUICE will study 3 of the Galilean moons, Europa, Ganymede, and Callisto, which are believed to have oceans of liquid water underneath their icy crusts, and maybe even some form of extraterrestrial life. Of the 3, Europa is probably the one where life had the best chance of developing, since its combination of salty liquid water and tectonic activity may be just right. But Ganymede is the largest moon in the solar system and may be a good model for small planets orbiting other stars. JUICE will search for organic molecules essential to life and use radio waves to probe beneath the moon's icy crusts to find out whether indeed life could exist down there. What strange creatures might lurk in these dark, distant oceans is for another Jupiter mission to find out, and a challenge for the next generation of planetary scientists.